Hey everybody, this is a tutorial on how to complete your earthquake investigation lab. Alright, in this lab you are going to be using seismograph data from 3 cities, from Ogden, Utah, San Antonio, Texas, and Kenosha, Wisconsin. You are going to use those seismographs to find the arrival of the P wave time, the arrival of the S wave time, and then calculate the SP interval, the distance between those times. We'll use that for finding the epicenter of the earthquake by finding the distances. And finally, we'll find out how much shaking happened, right? Shaking is the amplitude. So we're going to actually do Ogden, Utah together, and then you will do the other 2 cities, San Antonio and Kenosha. All right, so here is the seismograph data for Ogden, Utah. And you'll notice the first wave to arrive right here is the P wave. The second wave to arrive is the S wave. And over here, the slowest and third to arrive is the surface wave. We can find the time of arrival by using the x-axis, which is giving us minutes. So at 0, this would be the moment the earthquake happened. And then we find the beginning of the P wave and follow that down. It looks like about 3.5 minutes. And then we find the beginning of the S wave. It looks like that is just before the 6-minute mark. Bring that down, so we're going to call that one 5.9 minutes. And then we can go to our data table and put that information in. So we have our 3.5 minutes and our 5.9. So to find the SP interval, that's going to be the difference in time of arrival. So the SP interval is how much time occurred between the start of one and the start of the next one. So we need to do some subtraction here to find the SP interval. So let's do our 5.9 minus 3.5 gives us 2.4. So 2.4 is our SP interval. Go down here and put that information in. All right, now we're going to use this information right here, the 2.4 minutes for the SP interval, and that will help us locate the distance that the earthquake actually happened from Ogden using this chart here. All right, so the difference between these 2 lines, right, so this shows how many minutes away the S and the P wave are. So this difference is actually your SP interval. All right, so we want an SP interval, a line between these that represents 2.4 minutes. And the easiest way to do this is to use a ruler. So now I'm going to mark my 2.4 on the y-axis. And now when I bring my ruler down, I can see actually these tick marks. Each tick mark is about 1 centimeter, right? So I need to find the point on this graph where the 2 lines are approximately 2.4 centimeters apart. So that means the bottom line needs to line up with the 0 mark, and the top line needs to hit that 2.4 centimeters. Now I have a 2.4 minute interval between these 2 lines, right? So here's my 2.4. It's the same as this length. All right, so if I carry this down, that's going to show me how far away the earthquake actually happened. It looks like from Ogden, the earthquake occurred about 1,600 kilometers away. All right, so I'm going to put that over here. 1,600 kilometers is my distance to the epicenter of the earthquake. And now we can go to the last page of your packet. You can see there's a map. And here we have Ogden, here we have San Antonio, here we have Kenosha. All right, and for those cities, we want to use our distance that we calculate. So Ogden, we said the earthquake happened 1,600 kilometers away, right? So go down to your scale at the bottom, find 1,600, right? So here's 0, here's our 1,600, and you have a compass. Put the pointy end of the compass here, right? And here's your compass, and the pencil end of your compass over here. And then you're going to take your compass and you're going to use it at 1,600 to sketch a circle. Mine's not perfect because I don't have a compass. Around Ogden, Utah, with a radius of 1,600 kilometers. So our earthquake happens somewhere on that circle. We don't know exactly where, we don't know the direction, just the distance. That's why we get a circle. Next, you're going to do the same thing for the other two cities, and you're going to look for where do the three circles intersect. That one point they have in common has to be the epicenter. This is the concept of triangulation, using three locations to identify a point in common. Lastly, we want to go back and we want to find the amplitude of the S wave. This is going to tell us really how much shaking happened during this earthquake. So let's go back up to Ogden, and I'll clean up some of this. All right, so determine the amplitude. We're going to find the highest point and the lowest point for the S waves, and then we're going to read that off. You can use your ruler as a straight edge. I'm going to read that over here and bring this side down also. All right, so it looks like this one's about 1.5 and this one's maybe 1.9. Don't worry about the negative signs. We're just going to use positive numbers here. We need the average of these two to know the amplitude. So to find the average, remember you add numbers together. So in this case, we have 3.4. And then you divide by how many numbers you added. So we had two numbers added together. That means we have to take 3.4 divided by 2. That's going to give us 1.7. So 1.7 is our average. And we will take that, and that will be our amplitude of our wave. Right now, once I'm done with the amplitudes for all of my waves, I'll be able to see in which location was there the most shaking of the ground with the S wave. I'll be able to compare those. All right, so this is how you collect all of your data and do the triangulation. You can let me know if you have any further questions.